Question number 2. This question is about electrolysis. Figure number 2 shows the apparatus used to investigate the electrolysis of potassium sulfate solution. We have power supply here. We have the inert electrodes are here. The result of the electrolysis, we can see that the gases are formed here, oxygen gas and the hydrogen gas. 2.1 is an AO2 question, and this question is from atom, ions, compound, and the electrolysis process. Potassium sulfate contains potassium ion K plus and sulfate ion SO4 2 minus. What is the formula of potassium sulfate? Potassium sulfate is a compound, and compounds are neutral. They don't carry any charge. Potassium ion is carrying plus 1 charge. Sulfate ion is carrying 2 minus charge. So we need to balance them. So it means we need one more potassium. So plus 1, and 2 minus, they will cancel each other. At the result, potassium and sulfate ion, they will combine together and make a compound. So we need 2 potassium and 1 sulfate ion to make a compound. So overall charge is 0. So the compound is K2SO4. The correct option is K2SO4. 2.2 is an AO2 question, which is from the required practical activity number 9. And the student need to use the figure number 2. The student need to apply their knowledge by using figure number 2. What are the volumes of the gases collected in the electrolysis experiment? Volume of hydrogen in cm cube and volume of oxygen in cm cube. We need to find the volumes of both of the gases. Use figure number 2. In figure number 2, we can see that this is the area where the hydrogen gas is present. So this is 10 cm cube, 20 cm cube, and 30 cm cube. Whereas this is 10 cm cube of oxygen and 5 more cm cube. So overall, it is about 15 cm cube of oxygen gas. Students, they try to make a mistake there. They try to start counting the volume from here, but actually it is the solution or it is a liquid, so they shouldn't include this area. So the correct answers are 30 cm cube of hydrogen and 15 cm cube of oxygen. Let's see the model answer. So the model answer is from the figure number 2, 30 cm cube and 15 cm cube of oxygen. Two point three is an AO3 question, and it is from the required practical activity number 9. 2.3, a student made the following hypothesis, and this is from the topic of electrolysis. The volume of the gas collected in the electrolysis experiment are in the same ratio as hydrogen atoms to oxygen atoms in a water molecule. Explain how the volumes of the gas collected in the experiment in figure number 2 support the student's hypothesis. Use your answer to the question 2.2. If you look here in 2.2, the volume of the hydrogen is 30 cm cube and the volume of the oxygen is 15 cm cube. If you look here in question 2.2, the volume of the hydrogen and oxygen is 30 to 15, and it again become 2:1. Whereas in the water molecule, we have the same ratio, 2:1. So the above question 2.2 is supporting the student hypothesis. Let's see the model answer. The model answer is from figure number 2, the volume of the hydrogen gas is 30 cm cube, whereas the volume of oxygen is 15 cm cube. Therefore, the ratio between the hydrogen gas is double than the volume of the gas collected. We can see here 13 and 15, the ratio is, it is double to this one. So it supports the student hypothesis that the hydrogen is double than the oxygen in the water molecule. 2.4 is an AO2 question. The experiment is repeated 4 times. The volume of the oxygen collected in the experiment are given below: 6 cm cube, 9 cm cube, 10 cm cube, and 11 cm cube. The mean volume of the oxygen collected in the 4 experiment is 9 cm cube. The measure of uncertainty is the range of the set of the measurements about the mean. This line says the uncertainty is actually the mean of the range. The range is the difference of the highest and the lowest value in the data. If you look here, the highest value is 11 and the lowest value is 6. If you want to find the uncertainty, so we have the formula, the range is divided by 2. So the range is 11 minus 6 divided by 2. 5 divided by 2. That is 2.5. So uncertainty is more than 2. So the correct option is 9 plus minus 3. 2.5 is an AO2 question, which is application based question. The potassium sulfate solution has 0.86 gram of potassium sulfate dissolved in 25 cm cube of water. 25 cm cube of water. Calculate the mass of potassium sulfate needed to make 1 dm cube of solution. So this point is highlighted. It is required in dm cube, whereas the given information, the volume of the water used is in cm cube. The requirement of the question is we need to convert our units from cm cube to dm cube. Let's see what the values are given and what is a possible answer. In this question, we have the mass 0.86 gram of potassium sulfate. Volume of the water is given 25 cm cube. We need to find the mass of potassium sulfate dissolved in 1 dm cube of solution. So we need to find in 1 dm cube. So we need to convert cm cube into dm cube. We are converting a small unit into a bigger unit. Therefore, we need to divide 25 by 1000 to convert 25 cm cube into dm cube. Calculate the mass of potassium sulfate in 1 dm cube. So we need to find the mass dissolved in 1 dm cube. We want to say that it is actually the concentration of a solution. We have two formula for the concentration. The concentration is equal to mass over volume. Our concentration is equal to mole over volume. Mass is already given, that is 0.86, and the volume is given 25 cm cube, which we already converted into dm cube, 0.025 dm cube. So we can use the first formula, C is equal to m over V. Concentration is equal to mass per unit volume. The mass is 0.86 divided by the volume dm cube. So the answer is 34.4 gram per dm cube. Method number 2 is actually the ratio and proportion method. It is between the mass and the volume. When the mass is 0.86 grams, we have the volume 0.025 dm cube. We need to find in 1 dm cube of volume. The mass is unknown. We will consider it as an x. Then we use the ratio and proportion method. This is going to multiply this side. This is going to multiply with this side. So x is equal to 0.86 multiplied by 1 divided by 0.025. The answer is 34.4 gram.